I come from a Lianyungang Rheological chemical company. Okay, our booth is just over there. And we specialize in the production of processing additives, including homogenizer, physical peptidizer, and the flow and the dispersing additives, and the chemical peptidizers, and the tie and the rubber anti-ozone wax, and the pre-dispersed master bench. Okay, I will keep on my presentation. As we all know, the tire industry has required continued development in the area of increasing durability, better fuel economy, and improved safety. And all the requirements can be met by the improvement in rolling resistance and the skill resistance, especially on wet condition, and the wear resistance. And these are closely related with the hysteresis and the red friction behavior and abrasion of the titrate compound. Okay, compared with carbon black, silica has been proved to effectively reduce the rolling resistance and improve the retraction of titrate compound. However, a major drawback associated with the use of silica is processing difficulty due to the poor compatibility between highly polar silica and the non-polar hydrocarbon rubber. And the silica has high surface energy due to the selenium group on the surface, and tends to develop agglomeration, real hydrogen bonding, and form strong fuel network, and result in poor dispersion of silica in the rubber matrix. Okay, it is for this reason that silane coupling agent is often used to improve the rubber-silica interaction via chemical linkage. Where processing additives are also used to ensure better silica dispersion in the rubber compound. And the fatty acid derivatives are one of the most important processing additives, including fatty acid ester, fatty alcohols, and the fatty acid amides, and the fatty acid metal soaps. And the processing additives contain non-polar chains of different lengths, straight or branched, saturated or partially unsaturated, with polar groups attached to their ends. The non-polar groups of metal soap will reduce the surface or interfacial tension between rubber and the fueler, while polar groups show high affinity towards fueler. So the chemical structure is similar to surfactant and possess amphiphilic surface characteristics and can act as emulsification. Okay, in this work, 3 metal soap, zinc soap, potassium soap, and magnesium soap was adopted to study the processing characteristic and the rheological properties of silica-filled rubber compound. As we know, zinc soap is a common processing additive. However, recently we found that excessive zinc will be harmful to the health of humans. Therefore, it requires stricter control of zinc content. Potassium soap is an effective processing additive. However, the alkali of potassium is so strong that potassium soap is easy to hydrolyze and absorb water or say moisture. So the product is inconvenient to storage or transport. As for this reason, we develop magnesium soap, and we will compare it with zinc soap and the potassium soap. By the way, all the metal soap are produced by the reaction between fatty acid and metal oxide or metal hydroxide. Okay, first I want to introduce the my function of processing additive. As we know, that processing additives, the structure of processing additives is amphiphilic with a hydrocarbon end that is highly oil soluble and ionic polar ones. The nonpolar groups of metal soap are soluble in nonpolar or say, low polar rubbers such as NR, BR, or SBR, where the polar groups will aggregate and leading to the formation of spherical micelles or layered micelles in the rubber compound. On the higher shear rate, the layer micelles are easy to slip between layers, and it will reduce the compound viscosity and improve the flowability of the rubber compound. Okay, this is called internal lubrication effect of metal soap. The second, the processing additives can physically absorb on the surface of the filler and weaken the filler-to-filler interaction and reduce paying effect of rubber compound. Meanwhile, it can reduce the interfacial tension between rubber and the filler and improve the dispersion of filler in the rubber compound. One bifunctional silane coupling agent, for example, TSPT and the processing additives are both ended in the silica-filled rubber compound. Both of them will improve the dispersion of silica in the rubber matrix via chemical and the physical linkage. And next, we can see that with the addition with metal soap, the metal ions show high affinity to the metal surface of the processing equipment and absorbed easily. The processing additives can fill in the cavity on the metal surface. Even low-level metal soap can lead film formation. And the film is quite stable and withstand relatively high shear rate. So the thin lubricating film will greatly reduce the friction between the rubber and the metal surface. And it can significantly improve flowing rate of rubber compound. Okay, this is called external lubrication effect. Here is the formulation. And the addition of metal soap is 2 pHr. Here RF70 represents zinc soap. RF72 is potassium soap. And RF76 is magnesium soap. Here are the mixing procedure. Silica was added in 3 times in a small internal mixer. And the TSPT and the metal soap were added together with 1/3 silica and the first ending time. Okay. We have done the following experimental tests, including money viscosity and the paying effect, capillary rheolometer test, SEM analysis, curing characteristics, the mechanical properties, and the DMA test. Here is the results in the discussion. We can see that with the addition of metal soap, the mixing torque declined, okay, and the energy consumption decreased. It indicates that metal soap can effectively improve the processing ability of rubber compound. Potassium soap show better performance than zinc soap and magnesium soap. This is because the potassium soap has a stronger alkaline, and the potassium ion is monovalent and has lower steric effect. So potassium soap is easier to be absorbed on the surface of silica and improve the incorporation and the dispersion of silica in the rubber compound. From the picture, we can see that metal soap effectively reduces the money viscosity of rubber compound. As I has discussed earlier, the metal soap is considered to form micelle in the rubber compound. This is similar to the layer structure of graphite, and the intermolecular force between the layer micelles is so weak that the layered micelles are liable to be separated under the shear stress. So the internal lubrication of metal soap reduces the interaction between polymer chains and will improve the flowing ability of the rubber compound. Pain effect is mainly associated with the funnel network. We can see that the pain effect of the compound is reduced with the addition of metal soap. Potassium soap and magnesium soap show lower pain effect than zinc soap. Because metal soap has good welding ability to the filler, to silica. So the physical absorption of metal soap on the silica surface resulting in the decrease of funnel network strength as well as good dispersion of silica in the rubber matrix. From capillary rheolometer test, we can see that metal soap reduces the apparent stress, shear stress, and apparent shear viscosity, as well as viscous flow activation energy. It shows that the extrusion processing performance is improved with the addition of metal soap. Okay, besides of internal lubrication and the welding ability of metal soap, external lubrication should take into account and the relatively high shear rate. As discussed above, the metal ion is easily absorbed on the surface of the processing equipment and reduce the friction between the surface of metal and rubber, and can greatly increase the flowing rate of the rubber compound. From SEM micrograph, we can see that the dispersion of silica is not so good in the control sample, where when ended with metal soap, the silica particles became smaller and more uniform in the rubber matrix. Of course, the good welding ability of metal soap to silica result in better silica dispersion. From the table, we can see that metal soap shorten the scorch time and the optimal curing time. Well, the modulus and 100% and the modulus and 300% increase slightly, where the tensile strength and the elongation and the break and the tear strength decrease to some extent. And this is maybe related with the higher cross-link density of the vulcanizate. And due to the interaction between metal soap and the seleno groups of silica, it reduces the interference of silica on the curing process. So the curing rate and the cross-link density increase due to the activation effect of metal soap. And we also can see then the wear resistance is improved slightly with the addition of metal soap. The last, we look at the dynamic mechanical properties. We know that the hysteresis of tie compound is usually characterized by loss factor tangent delta. It is well known that hysteresis and high temperature show good correlation with rolling resistance of tie. On the other hand, has been readily believed that hysteresis and lower temperature relates to the high-frequency nature of dynamic strain involved in the ski process. Therefore, low tangent delta and higher temperature ranging from about 50 to 80 degrees, and a higher tangent delta and the lower temperature ranging from 0 to minus 20 degrees will be favorable for both rolling resistance and rad ski resistance. From dynamic mechanical analysis, DMA test, we can see that both of rolling resistance and the rad ski resistance are improved with the addition of metal soap. And this can meet the green tie requirements. The reason is that a metal soap has improved the interaction between rubber and the silica, and depress the funnel network and reduce the pain effect. And the last is the conclusion. With the addition of the 3 metal soap, the mixing torque, viscosity, as well as pain effect of the compound decrease, will improve the dispersion of silica in the rubber compound. Generally speaking, metal soap effectively improve the processing properties and result significantly affecting physical properties of rubber compound. That's all. Thank you for your attention.